Welcome to AI Podcasts. I am Ethan, and today we are digging into a fresh EMNLP paper called AgentInit.
I read the abstract, but give me the headline first. What is the one-sentence takeaway?
AgentInit shows that multi-agent systems work better when you spend a little time up front building the right team of agents, balancing who is most relevant for the task and who brings different strengths, and that simple shift gives steady accuracy gains with fewer wasted tokens.
So it is like choosing a project team instead of grabbing whoever is free.
Exactly. The authors argue that most failures are not because the model cannot think, but because the team is poorly composed from the start.
Who did the work?
Lead author Chunhao Tian with colleagues including Xuebo Liu from Harbin Institute of Technology in Shenzhen and collaborators at the University of Sydney.
Got it. What problem are they trying to fix in multi-agent systems?
Today, a lot of teams are created either by handcrafted roles or by auto-generation methods that dream up agents one by one. The catch is that those methods rarely consider how the agents will work together. You end up with copycat roles, everyone talking over each other, and long threads that eat tokens.
The meeting where 5 people restate the same point.
Yep, and the bill is paid in tokens and time.
So what is AgentInit doing differently?
2 stages. First, standardized agent generation. They use a planner to break the task into sub-problems, an observer to critique the proposed roles for a few rounds, and then a formatter that turns those free-form role ideas into a consistent schema, like clean role cards.
Clean roll cards, I like that. And the second stage?
Team selection. From the pool of candidates, they choose a team that balances 2 things at once: task relevance, meaning how on point each role is for the job, and diversity, meaning how non-redundant the roles are.
When you say diversity, do you mean backgrounds or skill coverage?
Skill coverage. Think of it as semantic diversity. They embed each role description, check how similar the roles are, and reward teams where the members are complementary rather than clones.
Right, like hiring a striker, a midfielder, and a defender, not 3 strikers who all want the ball.
Perfect. Then they look along what is called a Pareto front, which is just the set of teams where you cannot improve relevance without losing diversity or vice versa, and they pick from that sweet spot.
So they are choosing from the best trade-offs, not hunting for a single magic number.
Exactly.
What do they compare against?
A mix of single-agent setups and multi-agent baselines that either have fixed roles or auto-generated roles. They test across reasoning, math, coding, and even interactive environments.
And the models?
Big instruction-tuned models, including recent Quen and DeepSeek variants, so the backbone is strong.
Nice. Did they show the usual big table of results?
They did, but the story is simple. The gains are modest but steady across domains. Importantly, they also cut down on redundant chatter, so you see lower token use in many cases.
That is encouraging. Can you give me a concrete picture of how this feels in practice?
Imagine we have to plan a small science experiment with tools and rules. Without AgentInit, you might spin up 3 agents who all try to design the same protocol, argue for 10 turns, and then still miss a safety check. With AgentInit, you get a planner agent, a safety checker, and a tool user. They talk fewer turns because each one knows their lane, and the safety checker catches the oversight early.
That makes sense. How much of the improvement comes from better roll cards versus the Pareto selection?
They ran ablations in both matter. Standardizing the role descriptions helps because it makes the comparison fair, and the dual objective selection is the bigger lever. Optimizing only relevance gives you look-alike agents. Optimizing only diversity gives you quirky but unfocused teams, and the combination is where the gains show up.
How many rounds do they spend in that planner and observer phase?
A few. Enough to refine ideas, but not so many that you chase your tail. The curve flattens after a couple of passes.
Do they enumerate all possible teams? That can explode combinatorially.
For small team sizes, they can enumerate, and for larger pools, they discuss approximate selection, like evolutionary search, to keep it practical.
Okay, so it is not just pretty theory. What about really hard tasks, like advanced math or creative writing prompts?
The method still helps. On tougher math, you see a bigger bump, likely because complementary roles like a problem reader and a proof checker reduce those subtle misreads that derail a solution.
And on the creative side?
Gains are there too, because you avoid three agents offering similar bland drafts. You get a concept agent, a style agent, and a critic who nudges specificity.
I am curious about the cost story. You mentioned token savings, but there is an upfront cost to initialize the team, right?
Yes, you pay a small setup cost. The bet is that fewer turns during problem solving and fewer dead ends more than pay it back. In many benchmarks, that trade-off looks favorable.
Right, like sharpening the knife before chopping. A minute up front saves minutes later.
Exactly.
Any notes on generalization? If I build a team once, can I reuse it?
They test that idea. Teams built from a representative query or a small batch transfer pretty well to similar tasks, so you do not have to rebuild from scratch every time.
Good to hear. Now the skeptical questions, reproducibility.
Fair point. Results depend on current versions of large instruction-tuned models. Those can change. The paper describes settings and releases code, but perfect replication may be tough if the model providers roll updates.
And the choice of embeddings for relevance and diversity. If I swap in a different encoder, do I get the same Pareto frontier?
That is an open question. The method should still work, but the exact frontier can shift. I would love to see a sensitivity study with multiple encoders and diversity metrics.
Me too. And how about governance or safety? Team selection could favor agents that are clever but risky.
They focus on performance and efficiency, but the pipeline could accept human-in-the-loop constraints. For instance, require a compliance rule or forbid a plan that violates a policy and still run the Pareto selection under those constraints.
That would help teams in regulated domains. Any signs of overfitting to particular frameworks?
They show results in both chat-style systems and graph-based structures like chains and stars, and the trend lines are consistent, which is reassuring.
Okay, let us step back and translate the idea for builders. If I run a multi-agent stack today, what should I do tomorrow because of this paper?
3 quick moves. First, generate role candidates with a lightweight planner and a critic, and write the roles in a consistent template. Second, select the team using a two-objective lens, relevance and diversity, not just a score for each agent in isolation. Third, keep teams small and complementary so the conversation stays focused.
That feels actionable. Any pitfalls to avoid?
Do not mistake noisy diversity for useful diversity. You want complementary skills, not random roles. Also, watch the initialization budget. If your tasks are tiny, that extra setup may not pay off.
Where do you see this going next?
Dynamic reinitialization. Imagine the team can reorganize mid-flight when the task shifts, and cost-aware selection, where you put a hard budget on tokens or latency and pick the best team inside that envelope.
I would also like to see open weights replications, so smaller labs can validate without a commercial API.
Same here. Also, richer signals for diversity, like including how agents use tools or retrieve evidence, not just their text descriptions.
Before we wrap, remind us who to credit.
Lead author Chunhao Tian and colleagues, including Xuebo Liu, with affiliations at Harbin Institute of Technology Shenzhen and the University of Sydney.
Thanks. Quick lightning round. What is the single concept a listener should remember?
Treat team building as a design problem, not an afterthought. Pick agents that are both on target and different enough to cover the space.
And the practical takeaway for today?
Add a small initialization pipeline that standardizes roles and selects a balanced team. Expect steady improvements and cleaner, shorter conversations.
Final thought from me. Good teams win not because each person is brilliant, but because the mix is right. AgentInit brings that common sense idea to LLM agents.
Nicely said. That is our show. This is AI Podcast. Thanks for listening, and we will see you next time.
See you next time.